The limit as x goes to 2. We approach different numbers from either side, therefore it does not exist. The limit as x goes to 2 from the negative side, 2 to the minus 1 here. That is coming from the left side, which means you're coming up this arm here, which is 2. As you come from the positive side, you're coming down this, which is negative 1. As you go to 4, it's a vertical asymptote, so it doesn't exist. And f of 2 just says, what is the value of the function when x is equal to 2? 2. That's it. Do we feel okay with that?
Yeah.
Would it not be like for as x approaches 4, would it not be like positive or negative infinity?
If I said the limit as x goes to 4 from the positive side, what would you say?
Infinity?
Not infinity.
Or negative infinity?
It'd be negative infinity. Positive infinity.
Just the limit.
Yeah. Yeah.
Does not exist also work if it's a positive or negative infinity, or would you want us to specify? Because technically it's like, hey, the limit doesn't exist or infinity. Like either or is correct. Or would
Are you talking about one-sided limits or regular limits?
Like if it's if you approach a vertical asymptote, that word, it means that the limit does not exist or infinity.
What was that word you said?
Yeah, like so this one.
Yeah.
Yeah.
Like in that case.
You'd say does not exist.
You would say does not
Yeah.
exist.
If I said from the right or the left, I mean, I guess you could say it doesn't exist, but what I'm really asking, I know it's an asymptote.
Yeah.
I'm asking, is the asymptote going up, like to infinity, or is it going down to negative
But
infinity?
like if we said it goes to infinity for that, because it's synonymous in that case, does infinity also work in that case?
Yeah. Oh, I see. For E, if you
Yeah.
said it goes to infinity,
Yeah.
yeah, I'd give that to you.
Okay.
Yeah.
Because like technically it's not.
Well, that one, it doesn't go to infinity. It depends what side you go to. One side goes to positive, one side goes to negative.
This is.
We're getting into the weeds here. I'm not going to get
Okay.
this technical.
You won't get that finicky where you'll
Yeah.
be like, no. Lots of
Yeah.
months.
Just know that an asymptote does not exist.
Yeah. No. Asymptote.
All right. All right, peoples. 2 more questions. Go. There's your next 2 questions.
Mr. Belvin, you should post this to the classroom.
I will. The notes, you mean?
Actually, Mr. Baldwin's
This
in garbage
this
yet?
notes
Erase
plus
all
practice
this
problems plus whatever.
All right. I'm also recording. There we go. All right. Sorry, Noah. I forgot to record this. You're going to have to pick up where we left off. All right. So basically, split it apart. When you have a subtractive sign, you want to split it into 2. The numerator goes to both. So now I've got all this over x squared minus x cubed over x squared. Start canceling. The x will cancel one of those. This x cubed cancels all those. So I end up with, and now I break it into separate limits. The limit as x goes to 0 of 3 cos x times the limit as x goes to 0 of sine 17x over x. This is our special identity. Limit as x goes to 0 sine x over x. But what's in here has to match. So you can multiply the bottom by 17 to make them match, but you can't just multiply the bottom. You got to multiply the numerator by 17 as well, because that's really just 1. So this whole limit here becomes 1, and you're left with 17. So you get 17 times 1. If you put 0 into cosine, that is 1.
That is.
So you get 3 times 1 times 17, and then limit as x goes to 0 of x is just 0. So it's 51. Know how to do a question like that.
Why is it minus limit?
Because it's minus x cubed over x squared, which becomes x.
Yeah. Here's my how come it's like minus, it goes in the next one, minus limit x to infinity.
What?
Oh, okay, never mind. I see. So you made it 2 separate. Like,
Yeah, I just made it into separate limits. Okay. Are we okay?
yes.
All right. Tangent line, implicit, all munched together. There you go. What is the equation of the tangent line at 1/2 and 1 for the relation xy squared plus x is equal to 1? And then the second question below it is, what is the derivative of that thing? Best of luck. Posterity. All right. This is product rule. Product rule says the derivative of the first function, which is 1, times the second function, y squared, plus the derivative of the second function, which is, this is implicit. So you drop the 2 down, times y, times the derivative of y, which is y primed, times the first function, which is x. Plus the derivative of x is just 1. And the derivative of any constant is 0. So once you have this, at this point, if I'm asking for the equation of a tangent line, you actually don't need to solve for y primed at this point. You can just plug in your x and your y and then solve for y prime because it'll all just turn into numbers except for y primed. But anyway, I solve for it. I plug in x and y, and you get y primed is equal to -2. That is your slope because it's the derivative. Once you have your derivative, tangent line is the equation of a straight line or a linear line. So I got y is equal to mx plus b. I plug in my x, my y, and my m. Solve for b. The tangent line is -2x plus 2. You will be asked to do that on the test. Yes?
So what is the 1? The circle on the very far left?
This one right here? That is the derivative of this. Okay, and then everything else is just rearranging it. All right. Okay, so try the second one, please. X plus sine xy is equal to -17. That is a good test question because it's got this trig function in it.
Thanks for that, Bob.
I know. I'm just. So here's the second one. So we do the derivative of x with respect to x, which is just 1. Then I take the derivative of this thing. It's chain rule. Start with the outside. The derivative of sine is cosine. Then you do the inside derivative of this, which is product rule, which says the derivative of the first function, x, which is 1, times y, plus the derivative of the second function, y primed, times the first function, which is x. And that all equals 0 because that's a constant. The derivative of a constant is always 0. The trick here is to remember that this is all in brackets, so you actually have to multiply this in like that. Okay? You can't.
Where's the second?
So you actually have to multiply this in. Okay? So I get y cos xy, the 1 just hangs out, and then y prime x times cos xy, all equals 0. Now you solve for y prime. This garbage moves over here, becomes all negative. Divide out the x cos xy, boom, and there's your answer.
Okay, hey, just my question. So, how come, we probably covered this before, but how come when we derive x, it just goes to 1, and how come when we derive y, it goes to y?
Because I'm deriving with respect to x.
Oh, okay.
If these two match, it's just like regular derivative rules. If they don't match, it's implicit. So you actually have to say the derivative of y, we don't know what it is, so we just write y.
Okay. If it was like d over dy,
Then the y's would be derived. So the derivative of y would be 1, and the derivative of x would be dx, dy, or x prime. Okay? Are we good?
Yeah, that actually made a lot of sense.
All right. Leo.
Okay.
Leo's pouring some water into a tank. Go. Is a related rates question, people. You just saw the word cylinder and just shut down?
Pi r?
It is, yeah. Cylindrical, pi r squared h. Oh, and r, people, is 2. I forgot to write that in there. R is equal to 2 centimeters. The radius. Noah! Take the derivative with respect to both sides. 500 over 4 pi, which is 125 over pi centimeters per minute, or 39 point something per minute. I don't know what it is.
That was the most sensible problem made this entire year.
Are we okay? We're good?
Wait.
What? You don't need the height because it's changing. You're trying to find the height.
Well, you know what? This is like the most dopey my brain is just.
All right, let's go. We got to hurry up. We got a couple more things to do. Here is a table of information. I'm asking you to if h of x is f of x over g of x, I'm asking for h prime of 3. And I'm telling you the position function of a particle is given by this. I want to know the acceleration of said particle at t is equal to 1. Go.
Wait, what kind of question?
Record all this. Noah, you're the bane of my existence. All right, so h prime of 3 is the derivative of the top one, f prime of 3, times the bottom function, g of 3, minus the derivative of the bottom, which is g prime of 3, times the other thing, f of 3, over the bottom squared. Just pull all those numbers out of here. Negative 3 over 4.
I didn't do that.
What'd you do?
I didn't do that question. I was doing the math.
Oh.
I didn't really realize I was.
Okay. So does everybody, is that okay?
Yeah.
Maximilian?
No, I understand now.
Sure.
Sure. No, I do.
All right, the bottom one, if I say the position function of a particle, what do you do with that information if I ask about velocity or acceleration? Derive it. The first derivative of the position function, h prime of t, is the velocity function, which is that. You take the second derivative of the position, which is the derivative of the velocity, you get the acceleration function, which is 18t over plus 2. You plug in t is equal to 1, and you get 20 nanometers per second.
That's so
I know, I just made up the units.
No, it's very fun.
A nanometer? That's like 10 to the minus 9, isn't it?
Yeah. So you'll get somewhere eventually.
Eventually. I could have made it per hour. All right. Last question of the day, people. Answer that. Today's all about derivatives. Monday we'll do curve sketching and U sub stuff.
How do we get double prime?
I don't know. Ooh, I stumped Leo. It's like my goal. I'm saying, what is the value of f prime of 1? Given that's f of x. I should say this is f of x.
Wait, f double prime?
And then what is, or f double prime of 1, and what is f prime of 0? What are those values? And then the last three, I'm saying, what is the sign of these things? F prime on the interval 2 to infinity, f prime on the interval negative infinity to 2, and f double prime from negative 1 to 1.
Like, what are the exact values?
For these ones, I want to know the exact values. For these ones, I want to know, is it positive or negative?
Okay.
I highly recommend you know how to do this question. Want to come up with an answer?
You know the song?
Yeah.
Wow.
You know, you might
How do you find what?
I seem to have stumped people.
I mean, it's larger than 0, right?
Is it supposed to
For
be
what?
like
Or is f double prime?
is it supposed to be on both sides equal? Like
I mean,
is it supposed to be mirrored?
yeah, you can say it's a mirror graph. It doesn't have to be a mirror graph.
It's
Yeah, like it's
I don't have to come to this class every day, but I do.
it's
What? Sorry. Okay, are you giving me the answers? All right, so the first one, f double prime of 1. What does the second derivative tell you when you're doing curve sketching? Concavity. Where the concavity changes, what is the value of the second derivative? 0. So that's a point of it. It's called a point of inflection, right? So it's 0. F prime. What does F prime tell you about the graph? Is it increasing or decreasing, or the slope? So at 0, what do we have? It's supposed to be a max. I can't draw a graph. Okay. So it's supposed to be a max. What's the slope at a max or a min? 0. Okay. What is the sign of the first derivative on the interval 2 to infinity? In other words, what is the graph going up or down? It's going up from here on. So that means the first derivative has to be positive. And from negative infinity to 2, it's negative. And then from negative 1 to 1, I'm asking you about the second derivative, which talks about concavity. Is it concave up or concave down on that interval? Down. So it has to be know how to do a question like that. Noah.
Can we grab that?
Bye, Noah.